Hi everyone, this is a quick demo to show you how multi-CAD design studies are done using SIMSOLID. SIMSOLID is a new generation of structural design analysis software. It is intended to be used early in the design cycle to provide rapid insight on structural performance. A few things to remember about SIMSOLID. First, it's simple to use. It's based on new technology that uses high-order equations on a part and CAD feature basis and doesn't create a mesh. SIMSOLID works directly on the original unsimplified CAD geometry. Second, it's fast. It is typical to analyze large assemblies and get results in seconds to minutes. And finally, SIMSOLID is accessible. It's a small downloadable Windows application. It runs quickly on your desktop computer, so expensive HPC or slow batch cloud processes are not required. And all versions come with direct CAD integration to both SOLIDWORKS and Onshape. The modeling philosophy of SIMSOLID is quite different from traditional FEA. With SIMSOLID, assembly modeling is much easier. Multi-scale assemblies, big and small, or thick and thin, and assemblies with part connection gaps and overlaps are all easily processed. In addition, parts with extreme geometric complexity, small features, or poorly formed surface regions can all be included. The mesh-related challenges with traditional methods are not encountered with SIMSOLID. This makes setting up the model a snap. Now let's take a look at how design studies of large assemblies are done. Okay, let's start in SOLIDWORKS. Here's the assembly that we want to analyze. To do the analysis, we pick this button, Open in SIMSOLID. Open SIMSOLID and moves the model there. We can pick here OK to get automatic connections of our assemblies. Let's make our connections. Okay, there's the connections all done. There's our model. So let's do a quick analysis. Let's do a linear static analysis. Let's constrain up here in the throat. Let's load it, say, on this face here, maybe 1,000 pounds. And let's load this back face. The same thing, maybe minus 1,000 pounds. Okay, now we're all set, ready to roll. No mesh required, so I'll just pick Analyze. And you can see it. You'll see the status down here at the bottom. It creates the equations, then it will solve the product multiple times. Pass 1, pass 2, pass 3, writes the results, and we're done. Okay, so let's take a look. Let's look maybe at a displacement plot first. Maybe I'll look at the deformed shape. And actually, why don't I do an animation? So there's an animation of my deformations. Let me save that. Go back, stop that. Maybe I'll come up here and make a stress plot. And this time I'm going to zoom up over here and save that. Now I can go back to my model, say for example, and in fact, why don't we just save a nice image of just the model. So I got one more thing to save. Okay, but now let's say we want to do a second design study. We want to examine the impact of some geometry change. To do that, let's go back to our CAD system. Let's take a variation. Here's a variation of my model where I have a number of the parts that have been modified. I just simply go back in SIMSOLID, but this time you'll see that it says you have an open project. Do you want to go into a new project or the existing? I say, well, I want to go in the existing. When I do that, it'll put that change model into the existing project, but you'll see it makes it as a second design study. And in fact, it does a little bit more than that. It copied in, so here is our first assembly, geometry. Here's our second. But it also reassociated all the loads and constraints. So you can see here that I have a structural analysis all set up and ready to go as well on this model. So I have the same load, same constraints. All I have to do is hit Analyze here and I can get my second analysis. So again, this is an 85 part assembly. We're analyzing it a second time with design configuration change. And now I can go back and I look at there's my stresses for my first part. If you want to look at the stress for the second one, just simply click on it and you can get really quick changes. So there's stresses, first one, second one, etc. Okay, that's nice. But now let's assume that we have a third design change, and it's not done from SolidWorks. Let's assume we have a colleague that's modeling this in Onshape. How do we bring that in? To do that, we go up to this button here. It's our cloud browser, and now we're looking at our directory on Onshape, and these are different files. You can see I have a number of files there as I browse through them, right? If I want to get to my grapple model here, I have 3 configurations there as well. And let's say I want to get the second configuration. So um, simply open that up. Now I'm getting the model, but not from SolidWorks. I'm getting it from Onshape. But it also knows it's still a design study. It makes a third design study. It creates all the connections. And now it says, well, you know, these geometries all changed. So it says, I made the connections, but there may be a few that you need to check. So that's when you see something in red. You can go down here and say, yeah, those are the same, but I'm okay with that. So in this case, I just say accept all connections. And you can see it made my analysis, it made my loads and constraints, and everything's ready to go. So if I just pick Analyze, take the default materials, doing the analysis a third time. But what we've done here is we've gotten 3 design studies of an 85-part assembly. We've got 2 from SolidWorks, we've got 1 from Onshape, and we've got them in a form we can quickly compare all 3 of them. So let's look, here's my animation from my first one, here's my second one. You can see how the geometry changes. Here's my third one. So that's from Onshape, those are 2 from SolidWorks. Well, that's great, and I can look at stresses the same way from each of those. So I can very quickly scan through them. Okay, let's do one final thing. Let's say that we want to do an additional analysis case and we want to apply it to all 3 studies. To do that, let's go back to our model. Let's go back to our initial baseline design study, and I'm going to copy structural 1. I'm just going to copy it to the current design study because I want to edit it. So now I have a second analysis, and in this analysis here, let's just change the loads a bit. So let's take this and let's make that a load in Y, like that. And let's go back this one and make this another load in Y. Okay, so I very quickly have got my second study. Now if I want to take that, I can just copy it to all other design studies. And now I'll take that same set of analysis, loads, and constraints. It takes it from there's design study 1, design study 2, and design study 3. Now design study 3, again, I have these contact conditions that not completely sure since these came from SolidWorks. It wants me to confirm that they're okay, so I say okay. But at this point, I'm all ready to go. Now I just have 3 analyses to run, and I can run them all one at a time, or I can run them together in batch. But let's just do it one at a time. I come up here, I gotta run that one, and you'll see it's run by the fact that you see the results branch in the tree there. It won't take very long. So that's the first one. Here's our second one. And here's our third one. So let's go back and run that. So you see I'm running it it's a different load case for 3 different geometric configurations. And again, I'm doing it pretty much interactively. Okay, so let's just look at the animations really quick. There is the animation for, and we can close these down to make them a little bit easier to pick through. There's the animation for our structural 1 load case. There's the same animation for the same geometry but with our second load case, which we have this twisting applied. We can look at the same twisting on the second one or the third one. And we can go back and look at stresses exactly the same way. So there's stresses on the first case. There's stresses that are different. You can see that we have a little nice peak there on this torsional case, and there is for geometry 1, there's for geometry 2, and there's geometry 3. Well, one final thing we might want to do is look at the safety factors for all these different analysis cases. I can do that. Let's go back to our first structural one and let's look at safety factors. So I can go down and look at the safety factors here, and you can see that for the first one, everything's green, there's no real problems. Okay, that's great. But if I want to scan through this, I can go, there is my second one, and you can see that for the torsional case, I do have yielding in these areas. And I can also look at this. This is having a 25% margin over yield. I can zoom back down a little bit. There's even at yield, using this criteria, you can see we have a little bit of yielding. So okay, that's for that case. Again, for this geometry, but on the first load case, no problems. Third geometry, first load case, no problems. But if you look at the second one, the second load case is problematic. So, I would really want to go back and look at making another design. If that was the load that I was really trying to design to, I'd like to go back in there and make it a little bit stiffer so I can avoid this type of stress hotspot. Okay, but I think that gives you an idea of how design studies are done with SIMSOLID. Well, that gives you a quick overview of SIMSOLID. Maybe to summarize, SIMSOLID works on CAD geometry directly, without simplification, without meshing. It's capable of analyzing large assemblies. The assembly today was 85 parts, but many of our customers run hundreds and even thousands of parts with SIMSOLID. Accuracy is built in. You saw that every time we did a solution, we did multiple solution passes and measuring convergence of errors. So simple, fast, accessible. That's what SIMSOLID is. We call SIMSOLID simulation reinvented. Okay, you can follow us online at the links there, but really next steps may be going to our website. There's a lot of information in the white papers area. I have the link there provided. And if you want, everybody can just try it for themselves as a free 30-day trial in our download section. All right, thanks for watching.